All right, point B. Gus, what'd you get?
What did you say? Oh, it'd be 2 and then negative 4.
Should be 2, negative 3.
Hey,
In what quadrant is that?
quadrant.
Quadrant 4.
There's no 5 quadrants, there's only 4 squares.
Okay.
What do you mean there's 5 quadrants, bro? You freaking triangle this time?
All right, Paige, what'd you get for C?
0, 2.
0, 2, good. And that's not a quadrant, but what is it?
Y-axis.
Y-axis, good.
How do you know if you put the 0 or the 2 first?
So X is left and right. If you go left or right any, and then Y is up and down. So we didn't go left or right any, so it's 0, but we went up 2. What's D? Tanner, what'd you get
Oh, no.
for D?
7, 1.
Yep. And that's in quadrant 1. E. Andrew, what'd you get?
Negative 4, negative 2.
Negative 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Good. In what quadrant?
3. I'm so smart.
All right, and then F. Seth, what'd you get?
5 0.
Close.
Negative 5.
-5, 0. And that's not a quadrant, but what is it?
Exactly.
X-axis, good.
Quadrant 4.
All right, anybody have a question about that?
No, it's easy.
Okay, so the next thing is we have to know the difference between a discrete graph and a continuous graph. Discrete means it's just random points plotted throughout it. So a graph of
Chicken.
distinct points. So what that would look like is like if you have your little coordinate plane and you have random dots throughout it. That would be considered discrete, where you just have points. Okay?
Lines.
And then tonight,
Eating spaghetti.
why did I say tonight? I don't know either. Continuous graph.
Eating spaghetti.
I think you were talking about food. I'm hungry. I was thinking about food tonight. Okay. A graph with connected lines and curves. So there's a big difference between these two. You'll be able to tell quickly that continuous is a lot different than discrete. So continuous would be like if you have connected dots, so it makes an actual line or something, or curves. So that would be an example of a continuous graph. So one that just keeps on going over forever and ever.
My mom used to tell me to play connect dots. It was fun. And it would turn into like a drawing or something. She just randomly put dots in. I made a dog. I made a flower. I'm doing a hot dog. What?
All right.
I'm just talking about what my mom used to do. Just, you just make a grid and try to like put it like print a picture, cut out the picture and just put dots in the places. And kind of look into a dog. And I'd be just connecting the dots. She wouldn't even number it, I just had to figure it out. Sometimes I made just squiggles.
All right, on the back side. On this one, I want you to go through and label all these. Do y'all remember what domain and range is?
No.
Domain is your x values. The range is the y values. So for number 1, what's our domain?
Negative 3.
Negative 3,
-2,
negative 2,
1,
1,
3, 2.
and 3. Now, you do not repeat numbers that are being listed more than once. So we don't put -3 twice. We only put it once. And they make a little brace thing. That's what the squiggly thing. If you just want to put a bracket or something, just don't put a parenthesis. So on range,
What's the other one?
it'd be what numbers?
Negative 4.
1, 0, 2, -4, and 5.
Good. Now I like to do least to greatest, so I'm gonna put -4 first. 0, 1, 2, and 5. It's okay if you don't. But I try to put in least to greatest. So SOL will put in least to greatest. So just remember that. So then our table we actually write out the ordered pairs. So -3 goes in the X spot, 1 goes in the Y. Our second table would be -2, 0. Then we have 1, 2, 3, -4, and -3, 5. Mapping is the part that's new for you.
Yeah.
So you all have not done mapping before.
I'm sorry.
Mapping, you're going to do the domain. So -3, -2, 1, and 3. And then you're going to do the range. Now this one part does need to be in least to greatest. It will be cleaner if you do that. 1, 2, 5. And what you're doing on this is almost like connect the dots. You're matching them. So where does -3 partner up with on the range? 1. So you're going to draw a line from -3 to 1. Then -2, where's -2 going to go to?
0.
0. 1, where's 1 going to go to? 2. 3 is going to go to,
5.
no,
-4.
-4. And then -3, you're going to draw another line from -3 all the way to 5. So that is what mapping looks like. It kind of looks crazy.
Yeah, I did that one time last year.
But
Yeah.
not hard.
No, it's not hard. It just looks weird.
Whoops.
And then graph, you just plot your points. So I'm going to look back at the table, -3, 1. That'd be left 1, 2, 3, up 1. Then we have -2, 0. That'd be left 1, 2 on the x-axis. 1, 2, over 1, up 2. 3, -4, over 1, 2, 3, down 1, 2, 3, 4. And then -3, 1, 2, 3, 4, 5. All right, I want you all to try the next two on your own.